All right, folks, I've been working on this T962-2 motherboard, which goes to the T962-A reflow oven. And this broke back in 2017. I have my repair note here from 2017. When it was plugged into the mains while I was soldering on it for some reason. I don't remember why. But there was a very large spark and the magic smoke was produced and life was not good. I've since made some progress today revisiting this. I made some progress before when I was working on it as well. The bridge rectifier diodes had blown. The mains obviously comes in through here. And there was some burnt traces and stuff. There's two regulators here. I believe one's a 5 volt and one's a 3.3. It's actually labeled here, LT 3.3. That powers the microcontroller. But this cascaded, and from what I can tell, it did blow the microcontroller, which is an NXP LPC 2134. And the reason why I think it's blown is I went ahead and powered this up with 3.3 volts. I did look up the data sheet to find out where and how to do that. And I'll point some of that stuff out in case it helps somebody, maybe even me in the future. A couple things to take note. These two capacitors here are bypass caps for VSS and VDD respectively. So you can put ground here and 3.3 volt in here from your bench supply. You do want to check to make sure that there's two other pins over here. There's this one which goes to this point and the one above it, which are also VSS, VDD. There's also two pins down here, same thing. And then VBAT and VREF. I believe this is VBAT and VREF is like two pins over. It's this trace right here. Also connected to VDD. Those should all be at a 3.3 volt potential because that's what the chip expects according to the data sheet. Fortunately for my board, those are all connected. And by the way, VBAT is for the RTC clock timing. Those are all connected. The red light comes on when I apply power, which I suppose I could show you. Why not? There you go. But what does not happen, unfortunately, is so this is our connector here to the LCD screen. And for the longest time, I had thought that I had blown. It's like an active matrix cell. It's one of those old school style LCD screens. For the longest time, I thought that was the culprit because I got nothing on the display. And I actually have a few of these now that I had tried. I think the original was the one with this red backing that doesn't actually list the pinout. It says it's 5 volts, so there you go. That's probably why you need the 5 volt regulator in there. But some of these other ones do have the pinout, which is convenient because these are epoxy blob chips, which makes it a little bit difficult. But these can be found on AliExpress, these LCDs, and I'm not too worried that I won't be able to find it. I think eventually I'll be able to find something that'll work. However, when I boot it up, even on startup, all of the pins that are I/O pins on this output header, they get voltages like 3.3 volts or whatever, but that's it. There's no logic changing anywhere on any of them. From what I can tell, I put a bunch of them on my oscilloscope and it does not look promising at all, especially on power up. I feel like some of them should be doing something to at least to show the display that we get on startup, because it's got to produce that display from memory and transmit that somehow. Yeah, I'm going to go ahead just to be extra ridiculously thorough. I'll try every single pin. I think I tried half of them, but from what I can tell, it seems very likely as that chip is in fact blown. Yeah, so this is 3.3 volt potential. They're all just like 2.9 to 3.3 volt potential, 2.9 being a understandable nominal diode drop. Yeah, and judging from the pinout on one of the displays, this power chip over here is for driving the anode and the cathode for the backlight for the display. There's a capacitor here that I removed, a small ceramic capacitor there that I removed. I had a fuse going from the output. You can see I cut a little trace there, so I had a fuse just to add some sort of protection because this didn't have any protection. I also removed a transistor here, and then I think there was actually a capacitor, from what I could tell, that there was across those 2 points. Anyway, there's an ISP header down here, and someone has developed an upgraded firmware. And so I realized, well, you know what? If I have a spare chip, I can just put the upgraded firmware onto this thing, and then it should be working. Because I will have a working firmware. And so I'm actually really lucky in that apparently I had prepared for this exact situation and I have a spare chip. But I never soldered it on back in 2017. Maybe I got tired of this project. Who knows? In any case, I do want to try that. I believe it's programmed over UART through those FTD boards through a USB, USB interface and a driver chip. So I'm going to give that a shot. As you can see here, I cleaned up all the solder. There's all this really nasty flux that was everywhere from the work I did years ago. And there's a little bit of melting on this trim pot. I expect there to be possibly other issues. Might have to replace some of these caps. We'll see. And definitely the anode for the display is something I should look at. But I'm going to keep all the parts together, plop in that another chip, see if I can program it. I also want to make sure I got this crystal oscillator if this is working. Maybe I should check that now actually with my scope first and see if I'm getting a PLL oscillation signal. It's an 11 megahertz crystal, so that's actually important to check. 'Cause if no crystal, that would also make sure there's no activity. We'll see what happens, but I'm actually fairly optimistic if I can use this chip and reprogram it that I'll get something working here. It's a pretty good sign. And then the next step is just getting the LCD wired up accordingly. Not the easiest project, but it would be cool to get this working. More later. All right, making some progress with the controller board for the T-962A. And if you see now, it beeps, red light flashes like it's supposed to. I even get some garbled menu stuff. You can see it says NU. And there is a logo as well. So yeah, there's half of a logo. I have to remove this wire or it does not boot up. That wire is CS2 on the labeling here. Which is extension LED driver or LCD driver. It's extended display something. Anyway, I think it would account for why half the display is only showing. I tried swapping CS1 and CS2 around thinking they were chip select, but they're not. And I have a feeling that might be what's blown, but I don't know for sure. What's interesting is I've now got these pin headers on two other LCDs. These produce a blank screen of pixels. So it actually turns on and shows pixels, but it's all blocked out. And this is I'm quite sure this is the display that it had originally, which has no markings of any kind. I guess I could try to trace stuff out a little bit to these chips, but not to these ones, of course. And, these all have slightly different markings, 12864B, 12846-2, 12864D1, etc. And there is a data sheet that I got of these. It's quite interesting, but they all are very, very similar. The one thing that does seem to change, though, is that CS2, CS1. In the case here, it's PSB and no connection. And the PSB is if I remember correctly, it's for to decide if it's parallel or serial port. Read and write. E is actually SCK. It's actually a clock, very important clock. Obviously, the D ones are your parallel data coming in, anode and cathode at the end. V out does not matter. I disconnected it. Doesn't do anything, but it produces a negative voltage output. I guess if you need that for something on your microcontroller. VSS is ground. VDD is, I believe, 5 volts. Yeah, it's 5 volts. And so that's another thing worth noting. A couple things worth noting. One is you will not get this red blinking like ready light. It won't initiate at all if you don't have the 5 volt signal present, the 5 volt regulator, which also has to go to this guy, which also has to communicate back to the microcontroller. So if you don't have that handshake happening, it doesn't boot up. Precisely like you can find out if I connect this wire and, nothing happens. Since that wire is disconnected for CS2, you get the beep, you get the red ready light, and actually the menu's showing, which is great. I mean, that means I can actually run this thing with no visual indicator if I wanted to. Not that I really want to. But the question now arises, I mean, obviously I've got this other stuff to take care of later, but the big question now arises, I mean, I know the oscillator works, I know the chip works, I know it's programmed. I don't know if the EEPROM's okay, but, you know, we'll find out soon enough. Obviously, both the regulators are working, the contrast control, which is that 10K potentiometer, is working, obviously the piezo tweeter is working, and the brightness, or the anode driver for the backlight is also working. We've got these two other chips over here, which I think are mystery chips right now. But one's I think, an op amp. Maybe they're both op amps. I'll figure that out later. But getting close anyway. The interesting thing is that nothing seems to have blown directly on the 3.3 volt rail aside from the regulator itself. And if we look over here, how this damage was all done is this burnt trace coming in here from the high voltage. I guess it says AC 9 volts. So there you go. And, you know, that gets regulated down to DC, probably, I don't know, 10 volts, something like that, through the bridge rectifier, which then goes to pin 1 of this 5 volt step down, LM2576-5.0. One thing, important thing to note, this pin 1 actually goes to the end of those bridge rectifier, but the trace is broken. So really the only input right now is that pin 1. I added a fuse for the 3.3 volt regulator and cut the trace on the output. Also added a 0.1 microfarad capacitor. I don't know what one was there before. It might have been 10 microfarads. Interesting to see that this menu freaks out more and more. But whatever. So yeah, the question is, are some of these outputs blown on that chip? I'm going to try to reprogram it anyway, but I think that's the way to go, is to use the ISP header, reprogram it with the upgraded firmware, see what happens. It's probably still dead. Then swap in the new chip, reprogram that one, see what happens. And if that fails, it's really going to be, I think, trying to source an LCD. I think that's what that's going to tell me. So if that happens, that would suck. I'll see what I can do about sourcing an LCD, because it's already been pretty damn hard. But these are, I believe, a 128 by 64 pixel, something like that, LCD. I'll have to look it up again. But as you can tell, these are all slightly different. These two are different in the CS2 pin stuff. And boy, does it matter, because I get a blank screen. And then this one is just a complete unknown. This is like the really old version, so who knows, because nothing's labeled, which really sucks. But we'll find out as we go along. That's it for this video. Segasonicfan signing out! Alright, here I am making some progress on my T-962A oven repair, Reflow oven repair. This might be the original LCD that it came with, because it actually has this screw in there. Maybe. I'm theorizing, not a far-fetched theory by any means, that the damage is actually the CS1 pin. So CS1 and CS2, according to data sheets I dug up, delineate between the two sides of the display, like probably 32 pixels and 32 pixels. And CS1 has a 580 ohm short to the power rail. Is it CS1? Yeah, it's CS1. CS2 does not. However, for some reason, it seems to stay booted when CS2 is connected and not CS1. I'm just thinking that's just a bug. It does actually still boot with either of them connected, but it seems a little bit happier with CS2. My guess is... anyway, it doesn't matter. But point being, I've got this now with the Flash Magic software. I've just exported the memory. So I've got it hooked up to the ISP header, which is hooked up to the FTDI controller chip, hooked up to USB to my computer. All you need is RX and TX and ground. RX and TX need to be swapped. And then there's a little trick to get the chip into bootloader mode. It's all over the internet. I'm not going to cover it here. Well, you need to short... Yeah, it's all over the internet. I'm not going to cover it here. However... the one thing I will cover to get into bootloader mode, if you are like me and you already have the upgraded firmware on here, if you hold these two pins together, you short these two, pin 1 and 2, on this connector, which is ground and F1. If you hold those together on power up, it will be in bootloader mode. Because that's a feature that the Swedish hackers added when they did the upgrade. So you can see here, my board is been through a lot, to say the least. Look at, that's where the damage, that's where it destroyed itself, which is the reason for this repair. And there's actually a broken trace going to pin 1 for our 5-volt regulator, our LM2576.-5.0. And so that's why the power is going in there directly. You do need 5 volts for the LCD. So I can't just give this 3.3 volt logic. Anyway, I'm going to go ahead and flash a new firmware, but I'm quite certain that's not going to fix it. But I want to give it a shot and just do this process before actually installing a new chip. But I'm quite certain pin 39 is bad, and possibly pin 38. And those control CS1 and CS2. Pin 39 is the one that has the 580 ohm short. So I'm pretty sure that's the culprit. More to come. Hey folks, Segasonicfan here, and I'm back with my T-962A reflow oven repair. We'll see how much footage I'm going to actually post of this repair. It's been quite a job. And primary thing that happened was, you'll see I cut the trace on the 3.3 volt out and added a fuse because there was a short at the 9 volt plug here, which is an AC plug, which blew out the bridge rectifiers here. By the way, this last one is actually a 5819, which is the diode for the actual step-down converter there. But the bridge rectifier converts it to like a 9 volt DC type scenario, and then that gets converted down to 5 by this guy. I've jumped this red wire here because the trace actually got damaged when it was blown. Really, really bad blow there in the traces from the short. And that 5 volts comes out and goes to this 3.3 volt reg, which then powers most of everything. The 5 volts for the there's a backlight. This, by the way, this chip is controlling the I believe the brightness of the anode cathode for the backlight on the LCD. And this controls the contrast, this 10K potentiometer there for the LCD. But most of the circuitry, I mean, I think this EEPROM might be 5 volts, or I forget if it's 5 volts or 3.3. But most of the circuitry, almost everything runs off the 3.3, including our main microcontroller. And in the case of this guy, this is the old one. This guy blew up when the power stuff blew up, which is really unfortunate. And by the way, what you'll find when these break, what usually happens is the VDD and ground pins over here will start to short to one of the outputs, or one of the GPIOs, I should say. So it's basically the part that drives the LCD is the most sensitive part of that chip, and so that's what is actually going to break first and foremost. And so what I'm doing is going to be replacing that with a new chip that I had to get off of eBay because these are actually out of stock now, which is does not bode well for folks trying to do this repair. Hopefully these will come back into stock, or I don't know, some kind of alternative. And additionally, the display is very hard to source if you don't know what you're looking for. It's the KS0108, something like that. What I ended up doing, which I wish I had done a long time ago, was looking in the custom firmware that the Swedish hackers came up with. I forget their exact name, but there's a very popular firmware that can replace the firmware, the stock firmware for these, and highly recommend it. It's very good. But I had the darnest time finding an LCD that matched because there's a ton of 164 by, or it's 140, what is it, 164 by 48 pixel LCD that look exactly the same. And they all have these kind of unmarked glob chips on the back. And they're all just, so many of them are slightly different. So what you really have to do is go into the code and look into that in the firmware code, and there's a controller chip for the LCD that has to match. So if you're unlucky like me and you've actually blown the LCD as well, that's the thing to look out for. I was able to source one on eBay at the time of this video, but who knows what the future will hold with sourcing these old LCDs now. Now you'll see this trace is missing, but that doesn't actually go to anything. It's just, you know, it's an empty trace that's just a pad for, you know, mounting or whatever. So, and in fact, in really cheap boards, you'll find that they actually completely just don't have pads, which, you know, a good way to save money, I guess. Save a fraction of a penny if you need to. But, yeah, so I'm just going to be applying some NC559 aka Amtech liquid flux here. I'm going to put the chip down and get my trusty heat gun out, and then I'll go over it with the chisel tip doing some drag soldering if needed, which is, you know, always possible. And then after that, I'm going to reflash the firmware, which is very essential. I have to make sure my marking's correct here. They didn't use the typical dot, which you use for pin 1, but instead they use a little nicked corner there. So I'm going to go ahead and do that. Take care of that guy. And align this. And the thing about reflowing is, fortunately, you don't have to align it perfectly, but it really helps if you can get as close as you can. The surface tension will actually move the chip to align pretty accurately. And yeah. We'll see what we can do here. Sometimes you just gotta take your time and get it all there. Obviously the white silk there is gonna help with alignment, and that's pretty good. The one thing I did forget to do, which I won't say so much forget as just didn't do, was re-tin the pads with some fresh solder. And the reason I haven't done that is because I've already had to reflow this chip with the old one. I replaced it. Two of them have broken now. It's a really fragile chip. Plus, I was stupid once. So, I've been working on this over the years. Made some mistakes in the past, and yeah, those traces are becoming quite fragile. They were never high quality, you know, trace pads to begin with, but they're certainly on their last legs now. So I want to make sure to give them adequate. You know, make sure not overheat them. Not, you know, when you keep heating and reheating circuit boards, it's the kind of adhesion of the traces to the actual substrate becomes a problem. They start to flake off and break off and stuff, just like that one I showed you that was already broken off previously. What I'm doing is actually, I was going to see about elevating this so I could do the reflow. I have to elevate it a little bit because unfortunately my microscope base is like a solid aluminum. It'll just absorb a lot of that heat. I've had that cause problems for me before. Might be okay in this circumstance though. We'll see. We'll see. And I really need to be running my fume extractor while I'm doing this. Not going as planned. All right, we have some amazingness, folks. we've got a working display! And most likely a fully working motherboard now, minus maybe the cold junction temperature deal that I need to add. Holy moly, that was quite the journey. As it turned out, I was correct when I did my measurements. CS1, CS2 were the issues. Actually, it was CS1, which had a short on the microcontroller, which I had to replace and reflash. And I reflashed the broken one first, just to make sure it wasn't a flashing error. But nope, in fact, that guy was toast. And this new one is not. This new one is working! Oh my gosh, I'm excited. This thing's been quite the journey. And I'm going to put it all back together now.